So in this video, I'd like to talk about a problem I picked from OpenStax. So in this problem, it is asking us to find the electric force on this particle, 2.0 microcoulomb, that is active when it is placed at the center of these four particles with different charges. And the four particles form a square with 1 meter. So in order to determine the electric field, we first have to assume that it's all charges are point charges with point masses, and that all charges are fixed in place. So that we could use the Coulomb's law when we're evaluating the electric forces. By charge model, opposite charges attract and the same charges repel. So by intuition, we can right away know that the electric force due to charge A is in this direction, charge D is in that direction, charge B is in this direction, and charge C is also in this direction. So with that, we can move forward. So first, we have to find R hat, then we have to find R and Q in order to evaluate the FE. The question has given us the Q, and this thing is just a constant. So the question has given us Q, both Q, so they have given us the both Q, but they didn't give us the exact distance between different charges. Oh, and when we're calculating the electric forces, the approach that I'll be doing is that I'll separate the net force for electric forces due to A, B, C, and D. So we're evaluating the force on A, B, then C, then D. So first off, I'd like to calculate the distance between A and this particle. And that is very easy. So if we know that the whole thing is 1 meter, so the distance between here and here is 0.5, here and here is 0.5. So by Pythagoras theorems, then the distance would just be 1/2 square plus 1/2 square root. And that is what I did here. So RA is just 1 over root 2. The next thing I'll do is to calculate this R hat. So for R hat, I could use the traditional way, which is to put RA in this direction divided by magnitude of RA. But right now, because we know the dimension of we know the dimension from the diagram, then there's an easier way to do it. The way is that we're essentially finding a normal vector that is pointing in this direction when we're considering charged particle A. So to have this direction, this is basically saying that because the horizontal component and the vertical component is the same by symmetry, as we can see in this diagram, because it is a square. So we know right away that if we're talking about this vector, we have to find a normal vector. This is 45 degrees, this is 45 degrees, and a quick observation could give us this equation. This value. So it will be pointing in the positive I direction and the negative J direction. So then we can evaluate the force that is acted on the test particle by A. We're just plugging in every values. So that is the FA. Then the same thing goes as FB, and then the same thing goes with FC, same thing goes with FD. So we have calculated four electric forces that is acted on the particle by A, B, C, and D. So in order to calculate the net forces that is acted on the two microcoulomb charge, then we just have to add these four electric forces with its vectors. So essentially, we're adding this one is due to force A. This is electric forces due to force B, due to particle B. So we add the four things to give us our final answer, and that would be the net force. That would be the not that would be the net force for the two microcoulomb charge. So thank you so much.